Hello, Year 10s. Good morning or afternoon or whenever you're watching this. This is going to be a mini lesson on electron configuration. I'm going to try and keep it as brief as possible, just so that it doesn't go on forever and it's not a massive file to upload. But if you have any questions after this lesson, please post on Daymap or email me. I'm going to post my email on to Daymap so that you have access to that. And I'll be checking the Daymap page throughout our normal lesson time, and I'll be checking my emails throughout the day, so please do reach out. I want to make sure that this stuff makes sense to you guys, so thank you. Also, forgive me that I'm filming this in my bedroom, as you can see. Yeah, this quote up the back actually says, "Live life for the moment because everything else is uncertain." I put it up when I was about your age and it is just hitting home right now. Anyway, let's go. So we're talking about electron configuration, and what that means is for any given atom, how many electrons does that atom have and where are they arranged around the nucleus. So we're going to start by reviewing atomic structure. You should remember from previous lessons that electrons surround the nucleus of the atom. In this diagram here, we've got an electron here and the nucleus of the atom here. These two electrons just rotate around that nucleus. And you should also remember that the number of protons in an atom is the same as the number of electrons, assuming that atom is neutral. So for a helium atom, its atomic number is 2, so it has 2 protons and 2 electrons. So again, this should be revision. Basically just protons are positively charged and electrons are negatively charged. So what that means is that they're going to attract each other. They're going to want to come together, like the north and south poles of a magnet do, right? It's hard to pull apart a magnet or 2 magnets together. So because the protons are located in the nucleus, these electrons are going to be attracted to the nucleus and want to get as close as they can to it. So for helium, looking at this again, it's easy because it only has 2 electrons, so they can fit nice and close to that nucleus without any trouble. But for an element like calcium, which has 20 protons and thus 20 electrons, it's a bit tougher because you can see that if they were to fit in a circle like this, these electrons are actually really quite close to each other, but they're far away from the nucleus. And that's not ideal because the negative charges of these electrons are pushing each other apart. And the further you get away from the nucleus, the weaker the pull of these electrons. So they really do want to be as close as they can to that nucleus. So what happens is these electrons fit into shells. And we do call these electron shells. And this is the sort of image we're talking about when we say electron configuration. And you can also see how this is a favourable position for these electrons to be in, because these 2 guys, they're happy. They are so close to that nucleus. These guys, a bit further out, but still better than they were out here. You can see in this diagram here, going back, that they're all so far away. But back here, there's only these 2 guys that are so far. The rest of them are much closer. It's ideal. Yeah, so there are 4 shells that we're going to worry about because you're only ever going to be asked about the first 20 electrons in the periodic table. And electrons will fill the first shell first, then the second shell, third, then fourth. And they're labelled like that because based on how close they are to the nucleus, because the electrons want to be next to that positive charge, so they fill the closest shell to it. Now, our first shell contains 2 electrons. For atoms with more than 2, the next lot of electrons have to go into the second shell. So only 2 fit into the first electron shell. The second shell can hold 8 electrons. So when you're filling shells, 2 go into the first shell, then 8 into the second shell. The third again holds another 8 electrons. and the fourth shell can hold much more, but because you only need to know up to the first 20, just keep in mind that once you've filled the third shell, the next 1 or 2 electrons will go into the fourth. So let's practice. For an atom, for the element lithium, what does that electron configuration look like? Well, before we start this problem, how many protons does lithium have? I'm going to give you a second to answer. 3, and therefore it has 3 electrons. And I've added these little electrons here so that we can add them into the diagram. Now, the first one, where does that go? First electron shell. The second one, still in the first electron shell, but now that shell's full. So this third electron is going to go into the second shell. Hope that makes sense. Again, if it doesn't, reach out on Daymap, please, or contact me by email. We're going to do a more complicated example now. This is magnesium. Magnesium is number 12. We get that from here. So it has 12 protons and how many electrons? 12. So the same thing as lithium, we're going to fill the first electron shell first. It's got its 2 electrons. It is at max capacity. We're moving on to the next shell, which has 8. And these last 2 little guys here, they're all the way in the third shell. So what we did, we filled the first shell with 2 electrons, that's the max. We filled the second electron shell with 8 because that's its max. Then the last 2 electrons of the 12 go into the third shell. So I realize I've been talking kind of fast during these, and that's because you can't speed these videos up once it's in PowerPoint, so I don't want to drag it on. But if what I'm saying isn't super clear yet, this video here is amazing. You can pause it whenever you like, and it just goes through everything that I just explained. But again, highly recommend watching this anyway. It will help you with the next task that you're going to need to do. So this task is one of the ones that I gave you in hard copy in our last lesson. I've also uploaded it to Daymap so that you've got it as a digital version. It might be easier to do online to then re-upload it. Otherwise, you can just take a photo once you've finished your hard copy and upload that to Daymap. Hopefully, fingers crossed, if this lockdown's only a week, you can also just bring it into school. So instructions of what to do. You're going to need your periodic table that I gave you and you coloured in, or again, you can look one up online. And the first step is to write down the period numbers for each of these rows. And my pointer has gone away. Let me add it back in, laser pointer. So on these lines here, you're going to write what period it is in. And this is made to represent a periodic table. Here's the transition metals. Groups 3 to 12, they are just shrunk, which makes it a little bit confusing, but hopefully still makes sense roughly. So this one I've done an example for you. You'll put a 1 here. You can probably guess what would go next. You know, if we're going sequentially, all of the periods. Not every period is on here. As you can tell, there's not 7, but you get the general gist of what you need to do, I hope. Step 2 is write down the group number. So the groups are the columns. You would have group 1 here, group 2, then you've got your break for transition metals, and again they are groups 3 to 12. So then your next group will be 13, and I've just written here how I've gotten 13 rather than 3 because I recognise that it can be kind of confusing. It looks like it goes 1, 2, 3, but we do have all these groups in here that we're just not labelling. So 1, 2, 13, 14, and so on. And then the third step is to work out the atomic number and name of all the elements that have this little diagram. The reason we're doing that is because it's going to make it so much easier to draw in the electron configuration if you've already written down what the element is. Otherwise it's just confusing and you're looking back to your periodic table a lot. Yeah. So again, another couple of examples. We have hydrogen, period 1, group 1, 1 hydrogen. Then this one here I've labelled as element number 5, boron. So that's because it is in the second period, third group. And you can see that on your periodic table that that's boron. Hopefully that makes sense. And then the final step of this task is to draw in or colour in the electron configuration. So each of these circles represents where an electron could go if that atom has that many electrons. So in hydrogen, I've only coloured in this one here because hydrogen only has one electron and we always fill the first electron shell first, the most central electron shell. For boron, what I've done is I've filled in the first 2 electrons in the first shell. Then for the last 3, because we know it has 5 because its atomic number is number 5, so 5 protons, 5 electrons, I've put the next 3 in the second shell. So bringing us to a total of 2 plus 3 is 5. All of them are as close as they possibly can to the nucleus. So yeah, that's your task, is to do all of those electron shells that are on there. You might also find that it's easier to do once you've done this task here, because you've already gone through and named the elements, the symbols, protons and electrons, which is the main bits that you need for this task. So I would recommend doing this atomic structure worksheet first before you attempt the electron diagram worksheet, but it's up to you. That's going to be all for this lesson. Again, if you have any questions, post them on Daymap or email me. I really, really do want to make sure you guys learn this stuff and that it makes sense to you, because gosh, online learning is definitely harder than being at school. I want to make it as enjoyable and easy as I possibly can. So reach out if anything doesn't make sense, and good luck with your lockdowns. Bye guys.